Is 4 from Math 211. What you're asked to do here is deal with Babylonian numbers. So first, you're given a number in kind of our standard numeration system, 10,000, and asked to write it in Babylonian. So what you need to know is that in Babylonian, they had kind of these two different symbols, this for 1, this for 10, and they had this placeholder idea. So instead of ones, tens, hundreds, and thousands like we have, they had ones, 60s, 3,600s, and 216,000s. So if you're trying to express 10,000, you're like, well, 10,000 is less than this number here, so I don't need anything in this place. But in this place, I am going to need something. How many 3600s do you want? Well, 3 3600s would be too many. That'd be more than 10,000. You can check that with a calculator or something. So you want 2 of these instead. So the way I think about it is I'm going to want 2 3600s, and that equals 7,200. So if I've used up 7,200 of my 10,000, then what I have left is 2,800. So in this column, I'm going to write 2. So sure, this could be my final answer over here. And the way I write 2, just by making 2 of these little triangle guys, because each one counts as 1. And I got 2,800, and I'm thinking in terms of 60s here. Well, 4 60s would be 2,400, because 6 times 4 is 24. So 40 60s would be equal to 2,400. So that would leave me with 400 more. So how many more 60s is there in 400? Well, let's see. 6 60s is 3,600. Sorry, 360. And so if you add these guys together, you get 2,760, which is damn near my 2,800 here. So I want 46, so this is telling me I want 46 60s. And this is telling me that I want 2 3600s. And so those 2 3600s are right here. My 46 60s. Well, I don't want to draw 46 triangles when I can instead draw 4 of these. 1, 2, 3, 4 of these representing 10 each, and then 6 of these representing 1 each. So here are my 46 60s. But remember, we wanted 2,800 more instead of 2,760 more. So somewhere, I don't know, I guess over here, I'll take my 2,800, and that was this number. And from that, I will subtract 2,760, that was this number. And that'll kind of tell me how much more I need to account for. If you subtract here, you get 40. So what that tells me is that I need 40 ones. And the way I'm going to write 40 ones is over here. Instead of 40 of these triangle things, I'm going to write 4 of these guys. 1, 2, 3, 4. And so this right here in Babylonian would represent 10,000. Okay, and then you're asked to go backwards, so determine what number is being expressed below. I think these are easier. Maybe I should have made this 1 and this 2, but what are you going to do? So same basic idea. These are 1s, these are 60s, these are 3,600s. So how many do you have here? I got 21 1s here, which counts for 21. And then over here I got 10, 20, 30, 40, and then 1, 2, 3, 4, 5, 6, 7. It's a horrible number. So 47 of these 60s. So if I'm multiplying these together, I need a 0 for my placeholder, and then 7 times 6 is 42. So I'll carry a 4 over here, and 6 times 4 is 24. So I think 60 times 47 ends up giving you 2820, if I did that math right. So 47 times 60 gives me 2820, and then over here I have 4 times 3,600, which I wrote that pretty poorly. Let's try that again. And where those numbers are coming from is I'm representing 4 up here, but it's in the 3,600 column. When I do that multiplication, 6 times 4 is 24, so I'll carry 2. 4 times 3 is 12, so I'll get here. And so now what I want to do is take these numbers, 14,400, which is the value that I got out of my 60s place, 2,820, which is the value I got out of my 60s place, and 21, and add those all together. and that will be my final answer. So I add my 1s column and get a 1, a 0, a 2, and a 2 gives me a 4. A 4 and an 8 is 12, so I'll carry 1 up there. 4 and 2 is 6. 1 more gives me 7. I think what I'm figuring out here is that number that I expressed is 17,241. Whew. All right. Second page. Fill in the blanks below. So you were trying to write the base 10 number 100 in base 2. And so to tie this to concepts of our class, you are told you are buying 100 donuts at a base 2 donut shop. And in a base 2 donut shop, you can buy donuts in singles, boxes of 2, boxes of 4, boxes of 8, boxes of 16, 32, 64, 128, and so on. Although you won't need to go any further. In fact, you didn't even need to go to 128. And so what you're going to do is kind of fill out your order here. I don't want any boxes of 128. I'm trying to buy the biggest boxes possible because presumably it's cheaper that way. I don't want any 128 because that would give me 128 donuts. I only want 100. So I'll buy 1 box of 64. So I've already purchased 64 of my 100 donuts. I need 36 more. 36 more donuts? Well, we could buy a box of 32. That would leave me with 4 more donuts. 4 more donuts? Well, no boxes of 16, no boxes of 8, 1 box of 4, no boxes of 2, and no boxes of 1 should do the trick. So my answer is 1100100. So I like to write it with commas in there. I think it's easier to read. So I got this one, and then 100, and then 100. So in base 2, this number is the same as 100. Okay, what about 16? Kind of the other end of the spectrum. In our class, we'll deal with bases as small as 2 and as big as 16. So it's the same idea, I guess, in that we're at a donut shop, except now it's a base 16 donut shop. So our options are to buy single donuts in boxes of 16, or the next size up here would be 256. I think if you do 16 times 16, then you do 16 times something else again, but you won't need to. You can get bigger and bigger. Maybe I should have indicated that by like making this line keep going over here. Like you could make bigger, you just don't need any bigger. Same basic idea down here. You could make bigger, you don't need any bigger, because I can buy up to 15 of each type now because I'm in base 16. So how many of size 256 do I want? Well, 4 of size 256 would be over 1,000, because 4 times 250 is 1,000. So I guess I can only get 3 here. So how many donuts did I just buy? I don't know. Whatever 256 times 3 is. So let's figure that out to the side. 6 times 3 is 18. Carry the 1. 5 times 3 is 15, and 1 more is 16. Carry the 1. 3 times 2 is 6, and 1 more is 7. So I just purchased 768 donuts. Cool, but that's not enough. I wanted 1,000, so I need more donuts. So I need to subtract. 10 minus 8 is 2. That changes this into a 9, which minus 6 is 3. This is now a 9, minus 7 is 2. I need 232 more donuts. Okay, so how many 16s can I get into 232? I've been trying to avoid a calculator, although I guess you get a calculator, so maybe I make life easy for myself and I pull out a calculator. There's a calculator. And rather than guess and check my way through this, I'm going to do 232 divided by 16. And so what I'm getting here is 14.5. What that tells me is that I could buy 14 boxes of size 16. And to verify that, let me do some math over here. 16 times 14, try to show as much of my work as I can. 4 times 6 is 24. Carry the 2 up here. 4 times 1 is 4, and 2 more is 6. And put your 0 in as a placeholder and multiply by 1. Sum this all together. You get 224. So what I just did is I needed 232 more donuts. I bought 14, which accounted for 224 donuts. But that's not enough, because if you subtract those, you'll find that you still need 8 more donuts. That's okay, just buy 8 singles. So this is my number right here. And you're like, okay, so just write that here, 3, 14, 8. No, because if you write 3, 14, 8, it's going to look like 3 of this size, 1 of this size, 4 of this size, and 8 of this size. So when I'm in bases larger than 10, I need new symbols to represent the base 10 concepts of 10, 11, 12, any number that is larger than 10. So in base 16, I need a 10, 11, a 12, a 13, 14, and a 15. So what you've been told to do is to represent those with these letters. And so now I can translate this. I can say 3, 14, 8. I write as 3 E for 14 and then an 8. So that would be my answer right there. Okay, now you're going in the other direction. Now you are told that you have a number 1242 in base 5, and you're asked what is the base 10 representation of this number. You can do something similar to what we were doing above. Just think you're in a donut shop, and you're a base 5 donut shop, so your options are powers of 5, 1, 5, 25, and 125. And somebody placed an order. They placed an order for 2 of this size, 4 of this size, 2 of this size, and 1 of this size. Then you're asked the question, how many donuts did they just buy? Well, they got 125 from here. They got 50 from here, because they had 2 boxes of 25. They got 20 from here, and they got 2 from here. And so you sum those guys up. 2 plus 5 plus 2 is 9, and you get 197 here. And then, just because I kind of like base 16, I gave you this crazy problem, 4F5, which I'm tempted to get rid of. No, I'm not going to get rid of it. Okay, so in base 16, as we already learned, your box sizes are 1, 16, and 256. And so what we are doing, those are your 3 smallest box sizes anyways. What we are doing is buying 5 of this size, F of this size, but F we saw from before equals 15, and 4 of this size. So 4 times 256, well, 4 times 250 would be 1,000, and 4 times 6 is 24, so I get 1024 from this 4 times 256. What about 16 times 15? Well, 10 times 16 is 160, and 5 times 16 is 80, and 160 plus 80 is 240. So I'm going to get 240 donuts from here. Maybe I'll even like draw arrows. This gives me the 1024. This gives me 240, and this gives me 5. And those are the 3 things I want to add up over here. And if I sum these, 4 and 5 is 9, 2 and 4 gives me 6, 0 and 2 gives me 2, and I get this 1 for an answer of 1,269 donuts, I guess, if you wanted units. Whew, all right, I guess I'm going to end that here.